If I refresh, user's gone. So a couple of bad things. First of all, my user's gone. Second, still showing me the inventory. So let's fix the inventory bit first. Let's go back here. And what I'm going to do is I'm going to go to the inventory page. And in the inventory page, I'm going to say, let's do a component did mount. And let's say that if we had a username here, which we don't right now have, but we're going to pass down. But if there is no username, what we would like to do? Yeah, or they'd probably like sign in, because if you have no user, it's like, hey, sign in, right? This is what happens when you try to go to like eBay and you try to go to your account, but your account is restricted, so it will take you to your sign in first. So let's do that, and let's say we're gonna have a prop. We have the props of history, remember? So we can just say push to sign in. We don't currently have the username in inventory, I think. Let's check. So if we look at app, the inventory doesn't have that prop passed down. So what we need to do now is just do the same thing we did before with the sign-in form. We need to pass it all of the router props because we still want to have access to history, location, and all that. But on top of this, we're also going to be passing down the username, so we can see if this is a signed-in user or not. So when we do that, let's check back with inventory now. Great, so username now is coming from props. We have that username. Username, if it's an empty strings are falsy, right? So we're saying if there is no username, do this. Let's see if this works. So I'm going to sign in. Takes me to my inventory. Great. It didn't push me back because I have a username. But if I refresh the page, this time I lose the username and it pushes me back to the sign in as well. Because when the component tries to mount, it's saying, hey, you don't have a username, back off. Back to the sign in page. Cool? So we fixed that quite quickly. Now what we need to fix is the harder bit, right? The harder question of, okay, we need to store some information in our local storage because this is something that will stay there, will persist when we refresh the page. So that we can use that information to send it to the server, and the server can tell us if we're a valid user or not. So we need to validate our user. So for now, if we take a look at the sign-in form, what we're doing right now in this sign-in page is we're just sending the username to this signing method that we had in app, remember? So we can put that username in the store and state. What's also in data? What kind of stuff do we have in data?
History, notation. We
have history. No, that's in props. This is the data that comes back from the server after it authenticates me. You remember what it sends back? It sends back the entire user object. So if we look at the user's controller, what we actually get back is an entire user, right? So if we look at it, if we try to sign in, say, I can go into my network tab, I can see that a call was made to sign in, and when I check it, this is what's in data. This is what actually comes back from the server, right? And we said, yesterday we mentioned that, yeah, there's a couple of things we can use here to know who we are. So hopefully username, if username is unique, we can use that to identify it. But the safer way, the way to share less information is just to store this ID. Right? The ID is guaranteed to be unique because it's the primary key for that table, so it's never going to be a duplicate of anything. And also, if somebody catches this info, all they know is number one. They don't know much more, which is better. So, first thing I want to do is I want to clean up this data that comes back from the server, because the server is giving back too much information. Especially like, it's giving me my password digest. That's kind of not nice. Because if somebody holds on to this, maybe they can start like playing around, seeing if they can match the hash, if they can match the password. Right? So let's tighten up security, and instead of returning the entire user, I'm going to return the two things that I need, which is I want the username, so React can greet me and store me, and I want the ID, because I want to put it in local storage for later. So instead of storing this, sending back the whole thing, I'm going to say send back username and send back ID. So we don't have to send created at, updated at, password digest, and all that stuff. Just the stuff we want, right? We can customize this. This is just our own little JSON that we wrote. Username and ID. If we take a look at it, we refresh the page, it should still work. But when I check the sign-in, what I'm actually getting from the server now is just ID and username. That's a bit better. And the username we use to put it here in React. And what do we do with the ID? We want to put it in local storage. So I'm gonna change things like this. There's always many ways to do everything, but I'm gonna send the entire data to sign in. So that's gonna be my object with ID and username. And now I need to go back to app and I need to change the way I wrote my function, because right now this function is waiting for a string, but it's now going to be receiving a little object, right, with username and ID. So let's call this user, and let's say, okay, now the username is going to be there, and here is a good place to store that ID in local storage as well. So in any JavaScript, anywhere you are, as long as you're in the browser and you're not using Node.js, you have access to local storage. And you can do set item, and we're going to set an item, we're going to call it token, and we're going to store the user ID. That means that now two things are happening. We are signing in by putting Nicholas here, and we're also storing the number 1 in local storage. Let's see if that works. So when I refresh, when I try to enter my username and password, yep, Nicholas is there. And if I check the console, not Nicholas, if I type local storage, the token was stored. Which is great because everything that I put in local storage persists. Right? So even though my username is gone from React, I lost everything in React, I do have this number 1 in local storage. Right? And number 1 represents my user. So I can send this one back to the server and I say like, hey, which user is this? Nicholas. Okay, sign him back in. Without him having to type in the username and password. So what we're going to do now is we're going to create an endpoint to do just this for us. We're going to call it validate, because we're trying to validate that this is a valid user. And then this validate is going to do the same. It's going to get this ID, check if it's a valid user, and give me back the user. So going back, I need to go and change, first of all, routes. I'm going to create a new route. You would think that I need to write a post, right? Because I'm sending some info. I'm going to send the ID. But I'll show you a cool way of sending stuff in a GET request. Because later on, you might want to say like, get inventory. By the way, this is my ID. So you want to be able to send your ID even when you make GET requests, right? And to do that, what do you think we could do?
Serialize it?
No. What two ways do we have to send info? When you make a post request, or when you make a GET request, or you can get it from the URL, but let's say we don't. Because let's say I want to make a GET request to /inventory, and it will give me my inventory. I could, in a post request, I could send my ID in the body, right? Have we ever managed to add some extra info to tell the server something else? What about content type? Aren't we given some extra metadata about our request? Where does that go? In the headers. Right? So it turns out the headers are not just for content type. We could put lots of things in there. right? Any metadata about our request, we could put it in there. So we can actually create our own little custom header. We could call it token or authorization. And we can send our ID in the headers, which means I can make a GET request to inventory. My ID is not there. There is no body because it's a GET request. But I can actually still give you my ID in the headers. I can tell you, hey, I'm user 1. And we'll see what that looks like in a minute. I just wanted to give you an intro so you think about it. Yeah?
Is that how you would make a GET request with an API that requires authentication?
Yes. So, if you ever used an API that requires authentication, you may have noticed that they want you to fetch a URL. And they want you to make a GET request, but they still want you to put some headers in here. And they will ask for something like token, or the most common one is called authorization. And then you put the API key here.
Do you still have the method as get?
Well, in this case, you don't, because GET is the default. So if you don't put a method, it's GET. If you want to do anything except for GET, then you need to put the method.
There are some APIs that ask you to put the key in the URL. We did that.
Yeah.
We did that once. Yeah.
There's drawbacks to this, right? Like you're now storing it, like you have it in a URL in plain sight. It's, yeah, the URL looks way uglier that way.
Yeah. But it can be done.
It can be done, but there. Anyway, we're doing it through headers. And the way we're going to do this, we're going to create an endpoint. We're going to call it validate. And then we're going to say, okay, when you send a GET request to validate, I'm going to take you to the user's controller, and I'm going to check the validate method that I'm going to write. We don't have it right now, so I'm going to have to go here, and I'm going to have to write a method to validate my user. Cool. So let's see if we can put a bybug here. And let's see if we can do something like, go back here, make a fetch request. I'm going to make a fetch request. Ooh, lots of stuff. Too much stuff. I'm going to make a fetch request to this new endpoint that we created. Let's just make a fetch request for now. Go back to our code. Let's open the console. We reached the bybug. Means the route works. Let's see what we can do here. Great. It turns out that every request that we make, Rails receives this request as an object, and that request has a little bit of info in there. Just a tiny bit. Let's do that again. Yep, just a bit. Lots of information, metadata, parameters, whatever we need.
What did you type to get that information?
Request. What we want from the request is the headers. That's also a very small object. And what we can get from it is anything we want. So for example, if we wanted to get content type, well, it turns out we never sent a content type with this particular request. What if we did though? So let's do the same we did before, but let's add some headers. Let's add a content type. Send that again. First, let me actually, yep, go back there. So now we're back to the application. We'll make another fetch request. We'll reach our bybug again. And if I check content type, hey, magic. We sent content type, we received it here. Right? So you can see that we can actually send any kind of information we want through headers. Right? Which allows us to send info even when we're making GET requests. Any kind of request, post request, patch request, whatever we're doing, we can send our body, but then we can also send some extra data in the headers. So what we're going to be doing is we're going to be creating our own little header. Let's see if we can do anything here. Just to stick to that convention. Can we do? Yeah. Right, so we're not tied to specific things. This is quite arbitrary. We can send any header, put any value in. Cool? So what are we going to send in headers?
Authentication.
Yeah, my ID, right? The ID that we stored in local storage, I will send it to you in my headers. And we're going to call it authorization. Yeah. So we're going to say authorization. And in here, what do we put in there?
Local storage.
We can get local storage token, that token that we stored. We can do that. Let's see what happens. So if I make that fetch now, first I need to continue, I think, because we're stuck in there. Yeah. Look at that. And if I were to go back, and we change local storage token to 200, and I make the same request again, I can go back here, and we get that number, right? So we literally get anything that's in the local storage token. Right now, it's our user ID. Cool. So then, now that we know that we can do this, and that my user ID is in there, what can we do? How do we check if this is a valid user?
It's your ID.
Yeah, we don't know which ID, that's the problem. But so this is stateless, so we're not checking who we are. We're just checking that we are a user, right? So, well, we only have the ID. We don't care if it's my ID or someone else's ID. I just care if it's a valid ID, if it belongs to an actual user. So let's try to find it, right? Let's find the user with this ID. Is there a user that has this ID? Yes or no? That's all I want. So this is going to be my ID here. I don't know if you noticed that this is actually a string. So maybe, it's like that, right? Cool. So user, we're going to say user find by, and let's find them by ID. Why am I doing find by and not find?
Because you specify the answer.
But if you do find, it already finds by ID, right? I could do that and it would work if I find the user. But what happens if I don't find the user? It throws this red error, right? That breaks everything. So find by returns the user or nil. Which, if you're building an API, it's much easier to deal with, right? Because now we can return an actual nice message instead of this huge red error. So let's find the user by ID, and let's say if we do have a user, let's render. And again, we're going to render similar to what we did before. The username and the ID. Otherwise, we render JSON, and we're going to put an error in here. Cool. Let me continue. There we are. Go back. Try to make the request again. Great. It didn't work. Why didn't it work? So we got a 400. So it kind of did work, but we got user not found. Why? 200, right? So if you look at what current user we have stored, we have 200. There is no user 200. So instead, let's go back, change this back to 1. Try it again. Maybe parse it to see what we get back. That looks better. It's Nicholas. Right? So the whole reason we're doing this is because we don't want our user to have to enter their username and password every time. Right? Otherwise, every time they refresh the app or they navigate to a new page, they're going to be asked for the password again. That's really annoying. We want to prevent this. So we want a way to check if this is a valid user and which user it is, just with the ID. It's dangerous, right? We said it's not great because what if, let's take a look back, go back to our Rails API. Let's create a new user. Yeah, that's a lot of stuff. Okay. Create, we need a username. Great, now we have user 2. So what's going to happen if we store user 2 in our token? What are we going to get now? Yeah, welcome. You can now access Harriet's account without even knowing her password. Not very secure. But it does the trick in terms of we don't need to store the password. We don't need to ask them for the password again every time. So let's stick to this for now, and we'll make it better in a minute. So what we want to do now is we want to have that functionality, right? We now should have enough info to have the functionality we want that will allow me to create the password. So type this in, sign me in the first time, and when I refresh, keep me logged in, right? Or log me in again without me having to type username and password. We need to do that in the client now. The backend is ready. So what we're going to do is I'm going to go back to my API, and I'm going to write a new function here. And I'm going to call that function validate. And that function, what does it need? Does it need any arguments? It's going to be doing this, right? The same thing we did before. Do I need any arguments? What do you think?
That means you don't use our syntax and so
No.
This is just to get the token, or you need also the ID from the user to compare the local.
This is just exactly what we were doing before in the console. Check the ID local storage, send it to the server, see if it's a valid user, and we'll get back that. This is fine. We could pass the ID to validate, but I don't think there's much of a point because we're getting it implicitly from local storage anyway, every time. That makes our signature a bit easier. We don't need to remember to pass any arguments. We just say validate. Depending on whatever is in local storage right now. Now I'm going to add that here. So again, we can import validate directly by name, or we can import the entire API object if we want to. It's nice to have options. When do you think we need to validate our user? When would be a good time?
Every time it mounts.
Every time it mounts? So every time the app mounts, right? The entire application. That's right. We can do it here. I'm going to go to app. I'm going to add a component mount. And I'm going to say every time the application mounts, let's see if we have a valid user stored in our local storage. And if we do, sign them in. No need to ask them for the password again. So first thing we need to say is maybe if we have a token, because otherwise there's no point in doing this. If there is not even a token, what am I validating? Right? But if we have a token, we can say, do we have the API here? No, we don't. We need the API, so import, and we can get validate from, no, too far. Yeah. No, they're always replaced. There's only one thing there. So the last user that signed in, that's the user that we store. You cannot set, it's just a hash, right? You cannot have the same key multiple times. So if you have a token key and you set a token key again, what's going to happen? You're replacing the previous one. Great, so now we have access to our validate function. So we could just call validate. Remember that validate is now going to return some data. This is similar to what we did before in sign in. It's going to return data with either the user or an error. Right? So if it's an error, it means the user was not valid. Let's not sign them in. But if it's a user, then let's sign them in. It was a valid user. Right? So we can say if data error, maybe alert, like before. But if there is no error, well, that's my user. They managed to sign in. It was a valid user. Right here we can assume that the ID we had stored in local storage is valid. And we got a valid user at this point, so we can call the signing function, which is not in props because we're in apps, it's just here, this function here. We call it and we pass it the entire user. Right? The reason I call this data is because at this point we don't really know if the data is the error data or the user data. Right? It could be either when it comes back. The validate, I imported it from here. Cool?
Nico,
Yeah.
can I look at the validate function, please?
In the API?
Yeah, please.
Sure.
Why don't we do local storage.token.id? Isn't that more robust? Is there other things in there?
But we want the username as well. Also, there's no token.id, right? Token is just a string. Token is the ID.
Or is it object? Okay.
No, so local storage is the object. Local storage.token is just the string with the one.
We have one more quick look at the sign-in function as well.
This one, or?
Yeah.
This is just a post request. Nothing weird about
No,
it.
sorry, the sign-in function on the app.
Sure.
Right.
That one.
Yeah.
So we're doing a couple of things, right? We're saying set state, so put my username in there, push them to the inventory, and also store the token for later. Right? So we have the username, we put it up there. We have the ID, we put it in local storage. So we're saving two things in two different places. Cool. Let's see if that works. So now when I refresh my page, not instantly, because every time I refresh my page, my whole state is gone. But after half a second, I send that request to validate. Validate tells me, yeah, this is a valid user, is Nicholas. Okay, let's sign Nicholas in. Right? You can see the network that every time I refresh, we're making that request to the validate endpoint. And if we didn't have a valid token, and we check the network again, let's refresh the page. It'll tell me that the user is not found. And it just takes me back to the sign-in page because we haven't actually managed to sign in automatically.
When you sign out, you also have to reset the token.
Yes. So right now, we sign in, and let's say I want to sign out. The problem is even after I sign out, if I look at local storage, my token is still there. So when I refresh the page, even though I signed out, I'm signed right back in. So to fix that, if we're doing this in sign in, well, we do the opposite in sign out. So in sign out, we're going to say remove item token, and we don't need to say what's in the token, just like that. We could do clear, but what's wrong with clear? Clears everything. So what if we're storing more stuff? we would lose it. Right? So it's nice to be surgical and just get rid of the thing that we want to get rid of. Let's see if that works now. So we should be able to sign in, but when we sign out, and if we refresh the page, we're still signed out. In fact, because there is not even a token, remember that we're checking if there's a token? We're not even trying to validate the user because there is no token still. So what is the problem with this approach so far? It kind of works, right? It works pretty well. We can sign in, we can sign out, we can keep our user when we refresh the page, so that's great. What's bad about it? I can manually come here and set a token. Suddenly, I'm signed in without having to know my password. I can set it to 2. Now I'm Harry. Right? I can be a new user. I don't need to know the password. All I need to know is just ID. Yes, I need some. So we are partly there. We're almost there. But it turns out that storing this ID is not a good idea. Right? So we need a tighter way of verifying that this is a valid user. So what we're going to be using for this is a little tool called JWT. Have you heard of them before? A little tool called JWT, like this. Great. Stands for JSON Web Token. Some people say JWT, some people say JOT, like JUT. You can call it what you want, but it's a very useful thing, and I'll show you how it works. So far we looked at bcrypt for encrypting our password. But what did we say about bcrypt? What kind of encryption is bcrypt? Is it one way or two way? Can we get our password back once we have that messy code? No. So it's one way. So what we're going to do now with JWTs is we're going to have two-way encryption. We have an encryption that we can encrypt. We can also decode and see what's in there afterwards as well. To get that working, I'm going to have to go here and add the gem. Now that I've added the gem, I'm going to have to bundle. Great. Now let's see if we're in. Great. So now we have access to the JWT library. And the JWT library, just like I mentioned, has basically two main methods that we use. It's going to be encoding and decoding. Encode my data, decode my data. And it works like this. JWT.encode. I can type in here anything I want to encode, like. And then the second thing that I need to put in here is my secret. Right? And the secret is just a string. It's like a password. I'm going to use it to verify that this is a valid token that I'm storing. So when I decode it, I won't be able to decode it unless I have this secret. Kind of lying to you, but you'll see my point. So I'm going to type shh. That's my secret. Okay, so it doesn't want me to store. I think it doesn't want me to store plain strings. But no. But we can do this. Great. It doesn't want me to encode plain strings. It wants me to encode like either arrays or hashes. So I click hash, stuff, banana, right? Just some random stuff in there. When I go back, it looks very similar to the hashes that we were getting before for the password digest. But it's not, because this one can actually be reverted and we can get back our information if we notice it. So it works like this. I'm going to call this again. I know that this returns that token. This is called the token. I'm going to store it in a little variable called token. And now what can we do? How do we get it back? So we are going to call JWT again. We have a decode, right? We pass the token, and we pass our secret. And if we do it correctly, we get back our information, and it tells us also which algorithm was used to encrypt. Great. Generally speaking, you don't care about this much. You just want the first thing that comes back. So this is an array. We want the first element of the array. This is our data. So we can say dot first, and we get back our thing. Cool. If we don't enter the right token or the right secret, it's going to tell me that the signature was wrong, and it won't give me my data. Right? The signature is that secret. That secret that we use, it uses it to sign the code. So the code that's generated is going to be different depending on the secret. Now, you can store some info, but I kind of lied to you when I said that this can only be decoded with the secret. It's not true. So be very careful, and I'll show you what I mean. There's the JWT website. And here they can show you, they have like a playground where you can try it out and try different things that you can do. I'm just going to come in here. I'm going to type that token that I go back before. It's not very secure, but it's not meant to be secure. And I'll explain why. This, anyone can decode, and anyone can see the info. So it's a little bit secure, but not very much. The important thing is, I still don't know what the secret was that I used. So even though I know what information was here, I don't know the secret, and I cannot guess the secret. It's impossible for me to do it. So the reason we use JWT tokens is not to store data securely. It's to trust that this message comes from the person or the entity that we think. So in this case, my server sent me this message, and it signed it with its own little secret. Now, if I want to check that this is a valid message sent from a reliable source, I need to know that secret, and I need to input it, I need to be able to decode it. If I can decode it, it means, yeah, the message actually came from who we think it came. So this is just a way, JWTs are not a way to encrypt your data to keep it secure, but they are a way to sign your data to validate that they're coming from the person or the thing that you think it's coming from. So they're impossible to forge. It's easy to see what's in it, but it's impossible for me to replicate that signature and forge this request and make you think that the server sent this message. Right? Because this signature is a little bit here. It gets generated based on this and also the secret, and it's very hard to get. Yeah.
So the secret is not user level, it's server level, so it would be the same.
We can use it for anything, but for our application, what we're going to do is the secret is just server. It's an internal server. Mind if I get rid of this?
There you go.
Cool. So, like we were saying before, we're going to have the client, and we're going to have the server. What's going to happen is that the client initially sends the request the first time with username and the password. The server checks that I'm a valid user, and it will give me back my token, so that thing you see there. The client doesn't even know what the token is. It's just complete garbage. But it's going to store it in local storage. And then every other request that we make from that moment on, we're going to send it with our token. Now, the server has the secret in here. So the server will use that secret to encrypt these messages and send them. And it will also receive that token and use the same secret to decode the message and check if it's actually a message that the server itself sent. Right? So the server is sending messages, signing them, and then getting them back and checking if the signature is valid. If the signature is not valid, it's not going to do anything with it. It's not going to trust it. If the signature is valid, okay, it will decode it and use the info. Yeah.
So the secret is not useful to make that. So if you change the secret, it's going to be the same, right?
So everything is the same except for this bit. The blue bit is the actual secret. So if you look at the red bit, you see the color coding here? The red bit represents the hash that we used. The violet bit represents our actual information. And the blue bit represents the secret that we used. We don't know the secret. You can see that the secret was not revealed to me. Because it's impossible to reveal. I cannot know it. So even though I can see the info, I don't know which secret was used to this. So I cannot forge this request.
If you are a hacker or something, could you, because you have something to work with?
No.
I don't know.
Not with today's technology.
Who creates a secret? Is it the server or the user?
The server.
The server.
The server has the secret, the server encodes it, the server sends it, the server gets it back, the server decodes it.
So there's no
The secret, the client is completely dumb. All the client is doing is storing that token. Okay, you're dumb as well. The client receives that, stores it, has no idea what it is, but it just sends it to the server every time. So the server is the one producing them, and the server is the one decoding them. Right? Sends it, receives it, decodes it. But it's useful that the client stores it because now the client, if I signed in as Nicholas, I'm going to have a token proving that I'm Nicholas. Even though the client doesn't know what this means, the client will send it to the server. The server will make sense of this. It will say, yeah, you're Nicholas, this is a valid message, I can trust you. And then it will give you your information. But it's important to make the distinction because the common misconception is that because your data is encrypted, it's going to be secure. So don't, even though the data is encrypted, don't send credit card information and this kind of things. Like don't store these kind of things in local storage. Because anyone can grab it, go to this website and see your credit card number now. Cool? Right, let's have a 5-minute break. Okay, so, we know how to create tokens. We saw we can do that. I don't know what that even means. And we know how to decode the token. And with the right secret, it will give us back our information. So now what we need to do is implement what we said. So we need to be able to send tokens instead of IDs. And we need to be able to receive those tokens and make sense of them when we get them back. So the next bit of code is going to be, it's not very hard, but there's a lot of things going on. So follow along. Ultimately, what we want is when we sign in, instead of sending username and ID, I will send username because we want React to know our username. But instead of sending an ID, I will send a tokenized ID. I will send the ID encoded so it will look like random stuff. Right now, we cannot do this without first creating some little helper methods. Do you remember what this application controller does? So what's special about the application controller like compared to the user's controller? The hint is here. Look at that. Yeah. So if you see, this is inheriting from the original action controller API, but then everything else inherits from that one. Right? So that means that every controller that we ever going to write is going to inherit everything from this application controller. Which right now it's empty, but that means that anything I write in here, any functions, they're going to be available to me in any other controller. Alright, so this is a good place to write little helper functions that we're going to be using later on. In this case, let's create one at a time. So the first one that I want to create is the one for my secret. And this is, again, not a great way to do it, but it's nice to see why. So this is going to be a very simple function. It's just going to return shh, or whatever I type in, my secret. Cool? Now, we need to have a function that will get some data as an argument. It will encode that data, and then just give me back the token. using this secret. So the next bit we need to do is, we're going to call this issue token, and it will take some data, any data. I could put anything in here. It has to be a hash or an array. And then, how do we encode it? Exactly. We pass that data there, and then the second argument is what? Is the secret, which is going to be shh, but it could be anything, right? If I change this, that's going to change. Great, so we do that, and that's it really for this one. Yeah.
Could an employee that knows that secret just then hack everyone's accounts or want to find out once?
That's what I'm saying. This is not the best way to do it,
Okay.
but it's a start. We'll see how we can change that later on. But yeah, if you know the secret, you know the secret. You can hack anyone's account, but it's better than Facebook storing everything in a plain text file for every employee to see. But there are ways. So what you do later on is, instead of storing it here, you store it in an environment variable, and it will be randomly generated by machines instead of users.
Yeah.
Right? So there are ways to make that more secure. But let's start with the simplest case first. So, great. That should now be able to allow me to issue tokens. I should be able to call issue token, put any data here, and this will just give me back a token. Right? That's the numbers, real code that we saw before. I can issue it. What am I missing? So we said that we're going to send it, but then what happens when we get it back? We need to be able to make sense of it as well, right? So I'm going to have a decode token. We can even have a little token function here. And I'll tell you why. So, do you remember where the token is going to be sent to us? How is the user sending me tokens? Or how is the user sending me IDs before? Yeah, but the server doesn't care about local storage. How is the server receiving it? It's in the headers. There you go. Remember we had the headers? So where was headers? Can I just access headers like this? Do you remember how we got it? It's in request, headers, and which header was it? Yeah. So right now we're sending IDs, but we will be sending tokens eventually. So it's nice if I could just call the word token and it will get me whatever's in there. Right? It's a little helper method. So to decode the token, how do we decode it? Yeah, GWT or JWT, decode. You remember the... What do we need to decode the token? We need the token and the secret. We can get the token by calling that, and we can get the secret by calling that. Right? You remember what this returns? It returns an array with first my data and then the algorithm. But is there a possibility that this is going to fail? It could fail for two reasons, right? Why could it fail? The secret might be wrong. What if the token is not valid? Yeah, the token is just corrupt or invalid. So take a look at this. JWT, I'm going to say decode, and instead of passing the token in there, so a valid token, I'm going to pass some random stuff. And then I'm going to pass a valid secret. I get a decode error, right? Which is telling me that this is wrong. If I use the proper token, it works. But if I use the right token and the wrong password, I get a verification error. So it could fail for two reasons, right? Either because maybe the token is invalid or the secret is invalid. So what we're going to do is we need to have some sort of try-catch, because otherwise this will explode, right? This will break our application. Do you know how you do try catch in Ruby? Begin, and then the catch is rescue, and then end. So what I'm saying is, try doing this thing here. If this throws an error, something happens. If it explodes, instead of exploding the entire application, do whatever I will put in this rescue. Yeah, so this will protect me from crashing the entire app. Now I'm saying, okay, I think this is JWT. We can leave it empty. We can catch any errors. And I'm gonna say, okay, if it breaks, this function is just gonna return an empty object. But if it doesn't break, then this function should return whatever is in that first element of the array, right? So if this manages to work and we decode it, then give me the first element, which is that one there, right? In this case, it's stuff.banana. What I will actually be sending is ID 1, ID 10, ID 12. Cool. So now we should be able to call decode token everywhere, and we will get whatever token came back from the request, decoded, and the data itself, right? So if we send an object that says ID 1, we'll have access to that just by saying decode token. So the next bit, the bit that I'm actually interested in, is I want to be able to get this decoded token and to check if it belongs to a valid user ID. So did we get a valid token, and does it match a valid user ID? And if the answer is yes to both, then we're safe to give this user ID to access it. So we're going to say, I'm going to call this get current user, or let's call current user. And what we're going to do is we're going to say ID equals decode token. I think we need to say ID like this. Because it comes back, if you look at the way this comes back, it's similar to, remember the JSON library when you used it for Ruby? It doesn't give you back symbols, it gives you back strings as the keys. Which means if we do this, we're going to get the first thing. This is that object. If we say stuff, it's not going to work. But we need to say, if we say stuff, it's also not going to work. So we need to say stuff explicitly as a string. Where? First dot value. First is the hash. Which value are you trying to get? Yeah, it's So we need to use this syntax. In this case, we encoded stuff, but for a current user, what we actually be sending is IDs. So we want to get back an object that has an ID. We want to get back the ID value, right? The value of the ID key. So at that point, we should have a valid ID only if the token was valid, right? And if the token actually had a valid ID inside. And we can check now if this ID belongs to a user. In fact, we need to do to integer because it's going to be a string. Will it? We'll see. Let's try with that. Let's see later. We're going to say find by ID. So now whenever we call current user, all of these things that we said before, they're going to happen all together. We're going to get the decoded token. We're going to get the ID of the decoded token. We're going to see if we can find that ID. And we're going to return whatever comes back from this, which is either going to be a user or nil. If it's nil, that means it didn't work. If it's a user, it worked. Right? If it's a user, it means lots of things. It means we stored the valid token, we sent the valid token, and the token had a valid ID inside. So we can affirm all of these things. We're in a good place. We're in a safe place. You can access this information now. So let's see if this works. Right. I think we have everything we need to make it work. Now we need to start actually putting it into practice. So the little helper functions are all here. But now we need to first be able to send the token, because we still haven't sent it yet. So the client hasn't been storing tokens, right? What is the client storing right now in local storage? The user ID. We don't want to do that. We saw how dangerous that is. Anyone can just change it. So we're going to go back to the user controller. And when they sign in, instead of returning this ID, I'm going to return a token. And to get a token, because we wrote this issue token in the application controller, we can just access it from here, like that. We can call it, and we say, okay, what will be inside this token? What's the data that I want to put in here? Well, the data is going to be my user ID.
How are you accessing that?
Because I put it in the application controller.
Okay.
And then if you look at this, every controller inherits from the application control. Great. So yeah, the answer is all those helper functions that we wrote in the application controller, we can call them from here. Sure. Issue token. Very simple. It's calling JWT, encode what data I want to encode, and my key. Cool. And I also need to change this, right? Because I also want to change this. So when I validate the user, I don't want to send the ID. I want also to send the token here. So I'm going to change it in both places, here and here. And let's see how this works now. So we're going to have to go back to our client for a minute, and we're going to have to change something because we're no longer sending an ID field. We're sending a token field. Yeah. Cool. Oh. Why was there a C there? Oh, this is sign in. This should be that. I know what it was there. Because I did Command C and then probably without the command just type C. Thanks though. Nice spot. Right, let's take a look at now where we are getting this information. So if you look at the sign-in form, no, this is fine. We're passing the data in. The place where we're actually using it then is in app. We were getting a user object before, and the user object had a username, it had an ID. This is no longer the case. Now it has a username, and it has what? Token. So we need to say token here. I think that's the only place where we're using it. Ah, internal server error. Yeah, we'll fix that in a minute. I need to restart because I used JWT. Close, close, start again. Let's see how this works. If I type Nicholas and press submit, signs me in. That's promising. And if I look at local storage, right? This is the result that we got back in that issue token in our inside. And if we copy this thing, and if we go to the JWT website, you can see that this is the data that we encoded. So the data is visible. But just because the data is visible doesn't mean that anyone else can verify our signature, right? So this signature was sent by the server. So I can guarantee that this message was sent by my server. I can trust it. Even more, the server itself can trust it. When the server gets it back, the server can check. Is this a message that I issued? Yes? Okay, I can trust it. No? All right. We're not going to do anything with this. There's an error. You see it says invalid signature? Well, because we don't know the signature, but if you know it, you can verify it. Now it's verified. Going back, we're storing the right token, we're checking for the token, we're signing in, passing the data, everything seems to be working fine. Great. Now, when we validate, I think we did this the right way, so we're passing down the token. Right, so every time we validate now, every time we send in that call to validate, let's see what happens. Check here. I'm going to refresh the page. Great. User not found. So we broke something. Exactly. So let's take a look at what's happening though in the network tab. When I say validate and I look at my headers, before we were sending an ID in the headers. Now we are sending this token of the story. The validate method that we wrote is still expecting the ID. So it's not finding the user. So it's looking for a user with this ID. Which breaks. So let's go back. We need to fix our user controller. So the sign-in is working, but the validate is not. And the reason it's not is because we're doing this here. What's the easiest way we can find if we have a valid user from this token? I'll give you a hint. We wrote some helper methods here. We can literally just call current user and see if we get a valid user back. If you get a valid user, remember that we do all these checks. That means we have a valid token and it belongs to a valid user. Right? So all these complexities now here from our controllers, all we have to do is call current user. That's it. That's the beauty of this. So now I can go back here, I can get rid of everything here. And I can say user equals current user. Because current user is going to return my user, if it works, or it's going to return nil. If it's nil, user not found. If it's not nil, well, we have a user. Any questions at that point?
You have manually defined a secret.
Sorry?
You have a secret.
Yeah.
Do we manually have to define a secret, or is it going to be generated by?
You can go as far as you want to. You can generate them automatically, but you can also just store them like this. But I don't know if you spotted a really big problem with the way we're like using our secret right now. What's going to happen when I push this code to GitHub? So we're going to fix that later. But
if someone gets access to your backend, can they change the way that the secret is generated and then access it?
Sure, but if someone accesses your backend, they hacked you.
If you were to use, say, a bunch of integers to say a secret,
Yeah.
will you have any problems? No.
But you need to know which secret you're decoding with when it comes back.
Yeah.
Right? So if you do random every time, the secret you're going to use to try and decode it won't be the same secret that you use to send it. Yeah.
If you assign them random integer to a variable on initialization.
So the answer is you can rotate your secret. So you can make it so every day a new secret is generated. Right? So if a user was signed in yesterday, well, tomorrow they're going to have to sign in again the first time because they need to get a new token issued. Right?
There's no easy fix for it.
Not really. Cool. Let's go back. Let's see what happens. Okay, so we don't currently have a token. Let's sign in. Did it work? What's going on? Ah, we're in. Awesome. Let's refresh. Yeah, we're still in. What does that mean? That means that when we refresh the page, we sent a valid token, the server picked it up, found the valid user, and gave me back my user. What's cool about this is that, unlike before, I cannot just go here. I can see the token, that's fine. But let's say I want to change it. Let's say I want to replace it. I'm crafty. say token equals something. I don't know. I'm going to change something in here. Before it was very easy. We had a 1, we changed it to 2, to 200, whatever. What do I change this to? I can change. I don't know what to change it to. I could check the algorithm, and I could change it if I want to. So let's say I know my data is like here somewhere, but I don't know what to change it to. And even if I did, the signature here is going to be different every time I change that data. So even though maybe I can change this information, now the signature is invalid. So the server is going to get this message and it's going to say, failed to verify this. Somebody tried to mess up with this signature. I'm not going to use this.
What if I get someone else to store themselves sat next to his laptop that rolls on the same website and they just talk to people that might come towards that one?
Social engineering is always the best way of hacking people. What's the easiest way to hack someone? Lift the laptop and check the post-it note with the password. Right?
That's what I wanted. So that will work if I give it a store.
If you have the whole token, yeah. And this is why we use token expiration, right? So later on you can make it so let's change the secret that we use every day or every week or something. But yeah, I mean, if you have access to someone else's laptop, you have access to a lot of their information. Cool, but if I change this data and then I'm crafty and I say, all right, local storage, set item, token, I'm going to put this token that I forged in here. And then I refresh the page. It's just not going to work. So now I need to sign in again. Can submit. Now I'm in. And as long as the token is valid, we're still in. Takes half a second to sign us in. That's weird.
What about the key token? Yeah, like it's literally a string token that anywhere up can, like what about like
This is domain only, right? So that local search is only accessible from this domain. Every page has their own local search.
Oh, I thought it was like
It's not shared.
browser.
No.
Oh,
And it's a browser only for this website.
oh, okay.
So Twitter has their own stuff. If they want to store their own token, that will be the token for this browser, for this website.
So a user will look at multiple local storage.
Yeah. That's what we saw yesterday. Remember we checked Twitter? And the Twitter had a lot of stuff in there. It's a completely different version of local storage. So every page has its own local storage. So if I go to Google, or even just this one, if I open this, see this one is empty? If I go to google.com, this one has that stuff in there. So every local storage is a different version, right? Depends on which website you're in. So anything you're storing for this website won't be shared with any other website. They don't have access to it. It's segregated. Cool? So now let's do the final bit. What are we missing now? It's kind of quite there, right? So we can sign in, we can sign out. If we refresh, the local storage was cleared, so we're not automatically signed in again. I cannot sign in as Harriet now by typing 2. That doesn't work anymore. I literally need to be able to enter her username and password, right? To get her. But if I do know her username and password, I'm in, right? And now the token that we're storing is Harriet's token. The card is up. Right, so the final stretch is, yeah, we're in now. How do we display information that belongs to me, not just some random information? So let's go ahead and do that. So first thing I'm going to do is, okay, maybe let's go back to my inventory. We don't want this hard-coded stuff here. We're going to start off with an empty array. So we don't have any items. What do we need now to get our inventory? Well, we need a couple of things. We're going to need a route to get our inventory. We're going to need to check which user this inventory is for, get the items for this user, give them back, and then in the client, we're going to have to put the items here. Right? So a couple of things. let's start from the server. So the first thing I'm going to need is a new route. So in this route, let's call it get inventory. It's a custom route. And let's say it's going to go to users inventory. That means that I now need to go to my users controller and I need to create an inventory method. Right? So whenever somebody makes a GET request to the inventory endpoint, they're going to hit that method. Now, how do we get the items for the user that is currently signed in? Okay, where from? How do we get the current user? You can look at the top one. Yeah, but we don't need to care about this. All we have to do is call current user, because we already did all of that messy bit on the applications level. So again, we just do that. What will we get now? If Nicholas was signed in, we'll get Nicholas. If Harry was signed in, we'll get Harry. If anyone else was signed in, we'll get that person. Just by calling that method. Isn't that cool? As long as the user is sending a valid token to the request. So we do that. And now we're going to say, okay, if we have a user, so similar to before. If we have a user, what would you send back at this point? What do we want? The items. We have a relationship, right? Remember that a user has many items? So how do we get the items for this particular user? The user is here. That's it. Isn't that cool? User the items. I'm not going to get anyone else's items, just the ones that belong to me. And if that didn't work here for some reason, yeah, I think this is still user not found. That's fine. Or we can make a bad request. Cool. So the backend is ready, just like that, very easy. Now we need to make the request from the front end. So if we go back to the front end, what we need to do now is make a fetch request, make it to the inventory endpoint, and still you want to be able to send the token in the header, right? So every time you're going to send something, you need privilege access, you need access to my info, we're always going to send tokens in. When we send the token in, the server is going to be able to do all its work, check if we're a valid user, and will give us back the information that we want. Let's see if that works. Seems to be working, only I have no items. So let's go ahead and create items. I'm not going to go and do the whole create, post, and stuff. I'm going to do it the easy way now, because this is not the point of this lecture. You know how to build APIs. Oh, come on. There's always something. Seriously, the whole terminal is like not working? There we are. Cool. Let's create some items. So to create an item, we can say create. Let's make 2 items for each, like 2 items for Nicholas, 2 items for Harry. So let's say I'm building an RPG game. So I'm going to get a potion. This is going to be my name of the item. We call them name, right? Let's check our schema. Where's our schema? Config, db, schema. Item has a name, a description, and a user ID. So name, potion, description, recover some HP, and it belongs to Nicholas. Cool. Another item for Nicholas. Also. And now let's make a couple for Harriet. What do you want, Harriet? That's not very fantasy.
It is in my world. It's in my life. Black cat's not very fantasy.
It's a magic flat cat.
Okay. Can I have a magic cat?
No, you can have a cape. Right, so now we created a couple of items for each. We need to exit this, start the server again, check our application. All right, let's refresh. Invalid token. Oh, also, come on. I started the application and it started in port 3000, so it conflicted. So even though React was running in port 3000, that was also running in port 3000. Great. Let's go back. Refresh. Perfect. So Harriet's still signed in. I still don't see any items because we're not really fetching items yet in React. But if we do this, we're signed in as Harriet, so that means Harriet's token is stored. We can send that request. We get back 2 items. We get back the car and the cape. If we sign out, and we sign in as Nicholas, and make exactly the same request, now we get back the potion and the flat cap. Right? Because what we get depends on what we have access to. This is authorization, right? We're saying, I know who you are, but what do you have access to? So to finish it off, I'm just going to go back to my API. Error. I'm going to go back to my API, which is here. I'm going to use this function that I wrote. I'm going to say export function inventory or get inventory. It's going to take nothing. It's going to make that request, just like we were doing in the console. We can add it here in case we want it all together. And the last thing is just going to my inventory now. We add a component in mouse. So, well, look, if we don't have a username, push them back to sign in. But if we do have a valid username, we can call that function. We can say, we can call get inventory here, which is going to take no arguments. And it's going to get the, well, we need the API. That's going to be interesting. Okay, let's call this one set inventory. Now we can do get inventory from here. The problem is otherwise we're going to have clashing names. Now, put to deep. Yeah, we go to services, and API. So we have get inventory, and we can say get inventory, and then when it comes back, let's put the inventory right there. Oh, we called the items, didn't we? Well, let's call it inventory. Where is item? This is item. This is item. Seems okay. So now what we're saying is, when this component mounts, if we have it, don't have a valid username, push it back. If we have a valid username, call this function. Set my inventory. Let me see if that works. Yeah, items. Where's items? There we are. So if I'm signed in, I get my potion and my flat cap. And if we sign out, Harriet signs in, we get an error. What happened? What was the error about? Inventory.map is not a function? Where not? Why not? Ah. I think there's a problem with what we're doing here. No. The problem is we don't know if this is an inventory yet because it might fail for some reason. So we also need to check if we get an error here. But if we don't get an error, we do this, and we put that data in. So I think what was happening is we were always setting state, and if it comes back with an error, we were setting that error to state. And then we couldn't map because it wasn't an array. Right? It was broken. Yeah. So now if we're Harriet, we get Harriet's items. And if this doesn't work, it's going to be some asynchronous problem. Yeah. So initially it gets an invalid token. I think it's happening. Oh, I think I know why. I know why. So it's not working, but the reason why it's not working is because I need to do these two things the other way around. I was first pushing to sign in, but when I was pushing to sign in, there was still no valid token in there because we're only storing it later. So if we switch these two things, it should hopefully work. Cool? Nice. So we're trying to go there before the token was set. Then we were making a request to inventory, we were making the token. So that's why it doesn't work. Now, Harriet can sign in, can figure items. I can sign in, see my items. We can have a whole bunch of users, everyone with different access to different things. And it's just as easy from the backend as saying, give me the current user. That's going to check if we have a token. That's going to check if the token belongs to the user. It's going to get that user, and now we have access to our private key. We're done. Yeah, we're literally about to finish. Any questions? The hard-coded secret? Yeah, I'll tell you how to do it later. But the answer is you need to store it in an environment variable. So if you want to learn about that, do. I'll send you a little snippet of how you can fix it in your code later. How do you feel about the whole process? Story clients. There's a lot of stuff. And
It's not so many. Is that like a scaffold? Yeah.
if you
And also, I think it's quite repetitive to do like more or less the same thing. Is there any kind of framework or something that because it's very.
You can look at something like Auth 0, but then you need to learn how to use the framework, right? So it's going to take you probably more time to learn the framework than to learn how to do it this way. Cool.
The answer is yes.